Welcome to this Key Stage 4 lesson on the uses of alpha, beta and gamma. So before we start, I would like you to answer the following questions. State the penetration depth of alpha, beta and gamma. State what is meant by ionizing radiation and describe the dangers of ionizing radiation. You should know these from your previous lessons on alpha, beta and gamma. Pause the video now to attempt to answer these questions, and then I will go through the answers. So the penetration depth of alpha is around 15 centimeters through air, but it is stopped by a thin sheet of paper. The penetration depth of beta is that it will travel around a meter through air, but it is stopped by foil. Around 5 millimeters thick of aluminium will stop all beta. However, they will pass straight through thin paper. And finally, gamma. Gamma has an infinite range through air. It's not stopped by the air. And it can pass through paper. It can pass through 5 millimeters of aluminium. What it can't pass through is thick lead. So say 5 centimeter thick lead shielding, or a couple of foot thick of concrete. State what is meant by ionizing radiation. Okay, that is radiation which can cause neutral atoms to become ions. In all of the cases, they remove electrons from those atoms in some way or another. And describe the dangers of ionizing radiation. Okay, ionizing radiation can ionize your DNA, causing it to break, resulting in a mutation that could lead to cancer. So one use of gamma rays is sterilizing objects. Now, many of our foods are irradiated gamma rays in order to sterilize them. Foods like milk naturally contain bacteria which will spoil the milk over time. A very intense source of gamma rays is able to penetrate into the food, killing all the bacteria inside it and preventing the food from spoiling. The food will then last many years until opened, at which point new bacteria will enter and then spoil the food. This can also be used on medical equipment to make it safe for surgery. So it's very important to note here that irradiating food is not the same as contaminating it. When something is irradiated, it means that alpha, beta or gamma are passed through the material. But once that's happened, the alpha, beta and gamma are gone. They cannot cause any harm. That material is perfectly safe once there is no more source of irradiation. This is very different from contamination, where you may get some alpha, beta or gamma emitting isotope. So maybe you'll have polonium that's emitting alpha rays onto a food source or onto another thing that you may touch. This is called contamination. And contamination is very different from irradiation. Because if you contaminate something, that means you've put a radioactive substance on it that is constantly emitting ionizing radiation. Explain how a gamma ray source can be used to sterilize medical instruments. Explain why irradiating food is safe for the consumer. Now let's look at the uses of beta minus particles. So they're used in quality control systems. So when you're trying to get paper that is all the same thickness throughout, you'll use beta minus particles in order to measure the thickness of that paper. So when paper is manufactured, it's important to keep the thickness constant so as to avoid wasting material. When a beta minus source is placed near paper, most but not all of the beta minus particles will get through. If the paper is thicker, less beta minus particles will make it through. This can be used on a production line to control the thickness of the paper. Since the paper is squashed by rollers, the beta minus source and detector can be linked to the rollers to keep them the right distance apart. Too far apart and the paper is too thick. Too close together and the paper is too thin. The number of beta minus particles getting through can then be used to control that distance between the rollers. If lots get through, if nearly 100% get through, that means the paper is too thin. Whereas if very few beta minus particles made it through, the paper would be extremely thick. Explain how a beta minus source and detector can indicate the thickness of paper. Explain what happens if the paper is too thick, using the keywords beta minus particles and detector. Finally, let's look at a smoke detector. So figure E shows an alpha source emitting alpha particles, which ionizes atoms in the air. The charged ions can now carry electrical current between the electrodes. However, if smoke gets between the cathode and anode, it absorbs the alpha particles, stopping the air from being ionized, and therefore stopping the current from flowing. This sets off an alarm. So in the diagram you can see the alpha source. That alpha source is producing alpha particles which ionize the air, making some molecules in the air positive. This will cause them to move towards the negative plate, and so we have an electric current. State what a smoke detector is. Explain what happens when alpha particles are emitted between the metal plates, and explain how smoke stops the current flowing between the two plates.